Welcome back, everyone. Today, we're bringing you a focused explainer diving into the mechanics of the world around us, our natural resources. By the end of this session, you're going to have a rock-solid grasp of how we interact with our environment, zooming all the way out to macroeconomic impacts and then right back down to ground-level ecology. Let's get started.
Here's our roadmap for this explainer. We're going to define resources, categorize our world, compare functions versus services, explore the resource curse, look at global distribution, and then anchor the whole shebang with some fascinating real-world case studies.
All right, Section 1, Defining Resources. What exactly makes nature valuable?
Before we start classifying things, we have to ask, what actually transforms raw nature into a valuable resource? Think about an everyday object for a second. If a water bottle has a massive hole on the bottom, is it of any use to you? Well, no, obviously not, right? Because it can't hold water. But an intact bottle? Now that is incredibly useful. And this perfectly illustrates our fundamental concept of utility. Elements of nature only transform into resources when we, as humans, can actually utilize them to fulfill a specific need. Without that human use and utility, a material is really just, well, part of the background environment.
Okay, let's dive into this a bit deeper, because it's not just about being loosely useful. For something to officially be categorized as a resource, it has to meet three very strict conditions. First up, it must be technologically accessible. For example, we know for a fact there are valuable minerals sitting on Mars right now, but without the everyday technology to actually mine them and bring them back, they aren't a practical resource to us today. Second, it has to be economically feasible. The cost of extracting something shouldn't be higher than what the material is actually worth. And third, it needs to be culturally acceptable. Think about solar panels. We have the technology, it's highly cost-effective, and society globally supports clean energy. It literally ticks all three boxes perfectly.
Moving right along to Section 2, categorizing our world. Let's look at the ecosystem breakdown.
When we start breaking down our ecosystem, we first categorize resources by their origin. Biotic resources are derived directly from living organisms and the biosphere. We're talking about plants, animals, our sprawling forests, and complex marine life. Basically, if it's part of the living, breathing web of the Earth, boom, it goes right here in the biotic category.
On the flip side, we have abiotic resources. Remember, the prefix a literally just means non-living. So this covers the essential non-living components of nature: the air we breathe, the water we drink, the soil we plant in, the minerals we mine. Establishing this foundation is absolutely crucial before we start looking at how we put all these elements to use.
Now we can easily group these resources into three main buckets based on their primary purpose. First, you have resources that are absolutely essential for life: air, water, and soil. We literally cannot survive without these. Second, we have resources for materials. These are the physical building blocks we use to craft our world, like wood for furniture or rocks and minerals for construction. And third, resources for energy. This is the absolute cornerstone of modern living. It's what powers everything around us, whether we're using coal, petroleum, or clean solar power.
So let's see how this builds into the concept of renewability. Renewable resources are essentially inexhaustible, or at least they have this almost magical ability to restore and regenerate themselves over time through nature's cycles. Think about the steady blow of the wind, the daily arrival of sunlight, or forests that naturally grow back over the years. Conversely, we've got non-renewable resources. These are exhaustible. Because their formation takes literally millions of years under extreme heat and pressure deep beneath the Earth, they are entirely used up once consumed. The classic examples here are fossil fuels, like coal, petroleum, and natural gas. Once we burn them, they're gone for good. But hold on, because here is a massive warning flag for you. Even renewable resources can become permanently non-renewable if we aren't careful. If human activities disrupt those natural processes of restoration, like say we overharvest timber way faster than the trees can regrow, or if we heavily pollute our fresh rivers with industrial waste, we can permanently destroy a self-regenerating resource. It's an incredibly fragile balance. Section 3, Functions versus Services. Action versus benefit.
This next nuance is absolutely vital for truly understanding environmental science. Let's break down the difference between an ecosystem function and an ecosystem service. An ecosystem function is nature's inherent action. It's that automatic behind-the-scenes job it does, like a wetland naturally absorbing excess floodwater, or a tree naturally producing oxygen. But an ecosystem service, that is the direct human benefit we get from that function. So the tree automatically producing oxygen, that's the function. You, as a human, breathing that oxygen to stay alive, that's the service. Let's make it even simpler. Function is the action. Service is the benefit. Keep those two concepts clearly separated in your mind.
Moving into Section 4, the natural resource curse, also known as the paradox of plenty. Logically, you'd think a region blessed with massive natural resources would be incredibly prosperous, right? Well, prepare to be surprised. This brings us to a phenomenon known as the natural resource curse, or the paradox of plenty. It happens when resource-rich areas actually experience slower economic progress. Why on earth does this happen? Well, it mostly boils down to over-reliance. When a region strikes gold or finds massive oil reserves, the economy can become, frankly, a little lazy. They start relying entirely on exporting that one raw material and totally fail to develop diverse, value-adding industries like manufacturing or tech. And even worse, they often neglect human resource development and education, which we know is the true driver of long-term economic stability.
Section 5. Distribution and conflict. Power, trade, and settlement.
The harsh reality of our planet is that nature didn't exactly hand out resources equally, and this uneven distribution, it deeply shapes human society. Because fertile soil, fresh water, and valuable minerals are concentrated in specific areas, it heavily influences human settlement and migration patterns. It drives massive international trade networks as countries buy what they lack. But there is a much darker side to this. This imbalance also sparks severe disputes. For instance, when vital resources cross political boundaries, we see fierce conflicts. Just look at the intense, ongoing disputes between several Indian states, like Karnataka and Tamil Nadu, over the sharing of the Kaveri River. Resources literally represent survival and power.
Finally, Section 6, real-world stewardship, shifting from consumer to caretaker.
To really bring these concepts to life, let's look at how we shift from just being consumers to becoming active caretakers. Consider this number for a second, 80%. This represents a pretty stark crisis in the Indian state of Punjab. Back during the Green Revolution, a massive push for agricultural yields led to incredibly dangerous overexploitation of their groundwater. Today, nearly 80% of the land there is officially marked as overexploited, with water tables dropping drastically to 30 meters deep. It is a very sobering reminder of what happens when we extract a resource way faster than nature can recharge it.
But let's contrast that with another number, 20%. This represents an incredible success story over in Sikkim. Faced with declining soil health from heavy chemical fertilizers, Sikkim aggressively transitioned to statewide organic farming. By 2016, they officially became India's very first fully organic state. And the result? Achieving ecological balance actually boosted human prosperity. Farmers saw their incomes grow by an average of 20%, biodiversity returned to the area, and ecotourism absolutely boomed.
So as you can see, stewardship can take a lot of different forms in action. In Sikkim, it meant replacing harsh chemicals with simple things like compost, neem, and garlic. But stewardship is also massive technological leadership, like the Badla Solar Park in Rajasthan, stretching across an unbelievable 14,000 acres, generating thousands of megawatts of clean power. It's international cooperation, like the International Solar Alliance launched by India and France to fund global solar projects. And sometimes, stewardship is about combining ancient traditional botanical wisdom, like the texts of Rigshayurveda, with modern innovations, like eco-friendly alternatives to highly polluting cement. It is all connected.
And just like that, we've wrapped up our comprehensive review of natural resources. We covered the categories, the definitions, the complexities of the resource curse, and the immense power of real-world stewardship. But to close out this explainer, I want to leave you with a provocative question. How are you going to practice stewardship in your own life? How will you shift from just being a consumer of resources to an active protector of them? Keep that question in your mind as you go forward. Thank you so much for joining me on this learning journey, and I will catch you in the next explainer.